Hi, Serge.
Hello, how are you?
Good. And you?
Yes, very well, very well.
Well, so you are the product manager for the fertilizer distributor section,
Yes, that's it.
and so you brought us one of your machines, is that right?
Today we are going to talk about a double disc fertilizer spreader, the X50 Econov, which is present here.
I see it has two colors. Can you explain why?
Yes, indeed, two colors. It should be noted that the brand today is Sky and historically it was sulky. Actually, this system is designed to show the transition from that sulky blue to this new sky color. New brand that has existed for almost 2 years now. And now regarding the machine. This machine is made up of two main functions. The first function involves the hopper. At the base of the hopper, there are dispensers. One dispenser on the right, one on the left. Then, the second function is the distribution function to spread the fertilizer on the soil. So, in the operating principle, it is important to understand that for the dose per hectare, it is indeed the right and left dispensers that will allow you to adjust the flow rate, and this flow rate will translate into a dose per hectare depending on the speed, the width, and also the weight. This system is equipped with a solution for weighing. It allows the farmer to always know how many kilograms he has in the hopper. And this weighing function will allow measuring the flow occurring at the base at the level of the doser on the right and on the left, and that flow, we will compare it to the requested target dose. And if we notice a discrepancy, we will make an adjustment. The dosing system we have is an internal system that sets in motion the product we call a regulator and a trap door on the side. And the connection, the movement of this regulator with the trap allows for adjusting the flow. It is electrically controlled, and thanks to the software and the weighing function, we have very high precision. Today, managing the dose per hectare is something that is easy to handle. Following this dosing function, the product arrives at what we call the width chute. So, I invite you to come a little closer. On the machine, the trapdoor is on the side, and after the trapdoor, I have this system that I call the width chute. This width chute will channel the product onto the disc. And above all, make sure that the product coming out of the hatch arrives vertically. Thanks to this chute, we'll have a slide effect to help guide it into the blades and adjust the drop point. It's important to understand that the fertilizer reaching the disc will follow the path through the blades with one long blade, one short blade. And it will be thrown to the rear of the machine to land on the ground, and at ground level we will have a footprint. A footprint that, by the way, has a very large surface area. For example, when you are working at a 36 meters width with a good quality fertilizer, the spreading takes place over 36 meters to your left, 36 meters to your right, and a little over 40 meters behind. Overall, the surface area of the footprint on the ground is close to 3,000 square meters, 1/3 of a hectare. It's enormous. And when we modify the drop point with the chute, well, we move this footprint on the ground and position the footprint either very much at the back of the machine or on the side, depending on the desired width and on the product. Some products have interesting ballistic capabilities, will go far, others less so. Adjusting the drop point allows you to adapt the settings according to your product. So for these settings, there is an app in Sarah. There is a part in Sarah called FertiTest that helps you find the right settings based on the products. So I invite you to check out these application systems, the Sarah and the FertiTest, which is integrated into Sarah. The machine is equipped with a feature called speed control. So What is this speed control? It is a regulation loop. You need to understand that the layer of fertilizer at the back of the machine, this layer of fertilizer, it has a certain surface area and a certain distribution inside. If you drive at 5 kilometers per hour, 10, 20, 30 kilometers per hour, the distribution of granules inside the layer changes. And in fact, with speed, when you accelerate, you tend to put less fertilizer at the back of the machine and consequently increase the fertilizer on the side, which results in an increase in width. So in fact, it's something that we observed, and that was the subject of a patent. It's a joint patent with INRAE. To be able to make a correction. This is a correction that is made thanks to the drop point. The software allows for adjusting the setting based on the speed of progress. This is a very interesting point to note, which compensates for this phenomenon related to the speed of progress. This very interesting point. Another point to note is for the edge adjustment. So let's focus a bit on the system that is on the right side of this machine. The machine is equipped with a disc with blades. Here we have a long blade that allows it to send far. Just for your information, the blade has a particular shape called epsilon, which is also patented. This epsilon system allows for channeling and results in a strong jet at the blade's exit, improving range and enabling longer projections, thereby enhancing coverage. A long blade are short blades. Both will work for the full width. The drop point varies from there to here, and we have a particular blade here in the shape of a chistera. That's how people from the southwest speak. It has a chistera shape. It is positioned in front of the large blade. This blade will be used for the edge function. Thanks to this starboard system, my chute will position itself in this area. In this area, we have the edge blade present. This blade here is taller than the blade located at the back. This means that the jet taken here doesn't fall back there. It necessarily falls at the back. And you understand that this short blade bypasses this large blade, and as a result, we can perform the edging function to work along a road or along a field. Or, by the way, along a river. In these cases, we adapt two edging solutions. An edging that we call the yield edging. You are near the neighbor, you want to have good yield up to the limit. You use the starboard function in yield position at that moment. If you are along a river, then you will switch to environment position, and there all the fertilizer will be taken by the starboard blade, and we will not exceed 3 grains per 1,000. So, out of 1,000 granules that leave the machine, only 3 will exceed the limit to have a very strict border. That's the starboard border system, allowing work, so by default it is on the right side of the machine, and optionally it can be on the left side. One point I want to show you is the tarp system, which is quite interesting on this machine, especially a roll-up tarp. So we are going to lower the machine. Position itself as if for loading, and in fact this rolling tarp is controlled. Here I am controlling it manually, but it can be controlled hydraulically from the cabin. What is very interesting is that the rolling is done from the middle. So I open it. If you see, it's here that it rolls, and actually the outside stays stuck on the outside and the inside will go on the inside. So this little detail is very interesting, because if you have mud on the outside, the mud will stay on the outside. You will never put mud in the hopper. One of the first advantages. Another interesting advantage is that once folded and rolled up, it takes up little space. And if you load with a bucket, you will never put fertilizer inside the cover. So always a closure that will always be easier. There you go, we've covered everything. We can possibly look at the HMI, the software, the human-machine interface. I suggest you get inside the cabin to look at the software. The machine's software allows you to have different pages. The home page here is the work page. The job setting page, where we will do the basic settings, namely the width, give the name of the fertilizer and its calibration, possibly do a tear. Then we have another page, which is an information page with counters, surface counters, tonnage counters. The last page is more intended for technicians for machine settings and also compatibility with different isobus consoles if you have several, for example. I return to my home page. This home page displays the work screen that the user will have permanently with very useful information. At all times, we will know the weight of fertilizer in the hopper and ensure that this weight is decreasing and that it aligns with what we want. Below, the application rate per hectare. This is the general hectare rate. The left dispenser, the right dispenser, and some small pieces of information below, including the name of the fertilizer they're working with, and the forward speed. So here, I have set a simulated forward speed position. I will open the hatches with the series of buttons on the side. And when I open the hatches and start working, we actually visualize the spreading pattern. For your information, this crescent-shaped pattern, by the way, is a sky pattern, and it is indeed the actual shape of the pattern, of this pattern imprint on the ground. It has a crescent shape and not a straight line. If we want to make, for example, an edge, we will use a button here that will allow us to control what we call the starboard. First position, I have a starboard yield. Second position, I have an environment starboard, and if I press it, I return to the normal position. So an interesting little info you saw: as soon as it's green, it means it's working. When it's red, it means it's deactivated. Possibility to manually adjust. When I increase, you see, the slider fills up and I see how far I can actually go. So here I significantly increase the dose, but it allows me to know the machine's limit. These are the essential details of this interface. In essence, here we try to make things easy to use, easy to understand and easy to use. Of course, additionally, it can be used with GPS features such as section cutoff. Econov means that you can manage the width by GPS, especially with the TC and SC functions that are present in isobus consoles, as well as the dose modulation function by GPS. It's true that fertilizer is probably the most interesting product for practicing dose modulation by GPS. You first create a map on software, you put the map on the console, and then I have the ability to read and adjust the dose based on the location. The goal is the right dose in the right place. So regarding the dose, of course, you decide what dose you want to apply. Well, we'll end here. Thank you and happy spreading to you.